And we've been working very closely with a division of NASA called the Flight Opportunities Office. And they've been helping coordinate an interaction between the scientists and researchers and commercial entities with payloads that they want to fly on vehicles and ourselves as a launch provider. And so we do have a lined up list of payloads and a backlog of folks interested in flying to space. It's been a fascinating conference, listening to all the different research projects that people want to do, in the space environment. And we'll be starting sort of low-level suborbital flights with payloads, hopefully in the next few months. And the target is by the end of the year we'll be reaching the sort of official boundary of space and continuing to go from there. So, one of my favorites is our very first payload is interesting more because of what it implies than the actual payload itself. And we've been asked by the FAA to fly their next generation ADSB transponder. And this is the what all commercial and general aviation aircraft will be flying as the next generation system for in-air identification of where everyone is in relation to each other. And it goes from a passive system tracked by on-ground radar to an active system where every vehicle in the skies will be broadcasting their location to every other vehicle.
That's GPS-based, isn't it?
It's GPS-based, and it's in testing, among all the major, airlines and airliners at this point. And the interesting thing is that the FAA has asked us to fly this as an early rocket payload to demonstrate full integration of rapid turnaround rocket flights into the commercial and civil airspace on a flight regime. So every time we fly, everyone in an airplane is going to see that rocket, and I'm hoping they're quite confused for a moment. But the goal is...
What kind of plane is that?
Yeah. But the goal is definitely to move to a world where, rocket flights are as integrated into the standard airspace operations as any other type of flight, and therefore it becomes a routine event to launch a rocket with a payload and retrieve it. We have experimental payloads from several universities. Student payloads will be our first batch coming up. We are talking to people about doing a set of experiments that require to be done above the atmosphere, where they're filtering out sensitive astronomical information that doesn't really make it through the water in our atmosphere. So if we can get above the water, they can rapidly do sun sensing and look at properties of the solar flares, look at various stars and get certain pieces of information that don't require a lot of focus per se, but do require quick views above the atmosphere. We're talking to people about crystallization and other experiments that are interesting to do in micro-G. There's definitely some life sciences work that people are looking at understanding the properties of zero-G on cells and on plants, et cetera, as a precursor to possibly flying to Mars or elsewhere in space. We're the less researchy and the more commercial side of our flight business is oriented towards basically testing out components that you might eventually want to fly to the space station or on a space vehicle or on a satellite. So we can offer, a vibration modes of an actual, space vehicle. We can offer access to vacuum, access to microgravity, access to, on-demand G loads. And so we have a number of commercial clients who are interested in seeing what, in basically proving their space capabilities, which makes it much easier for them to get it rated as qualified to travel to the space station or to be part of a commercial satellite. Just talking to all the different people at this conference, there's clearly a whole lot of different payloads that we hadn't even predicted will be out there. So I'm quite curious to see what comes up over the next year or two.
Low cost, reliable access to space, to microgravity environments. In your personal opinion, is that going to be a game changer in terms of all the scientific disciplines?
I think it opens up one more tool in the toolbox. So let's put it that way. I don't know, and I don't think anyone yet knows the degree to which it'll change the world. We're still clearly in some point, amount of a if you build it, they will come model of an industry. I do think that there will be significant disruptive impacts in some field or other via access to routine suborbital flight and eventually to small-scale orbital flight. What those are, to some degree, remains to be seen, but I'm pretty confident that something will emerge. And even just the straight math of if you want to do Earth environmental sensing, for instance, the cost of a billion-dollar traditional satellite versus the cost of simple, a routine flight every single day on a launch vehicle, which lets you, in the interim, fix your equipment, upgrade your equipment, change your model on a per-flight basis, rapidly becomes, extremely cost-efficient. And you can choose where you want to do it, how you want to do it, what you want to look for, and we think there'll be, that's just one example of areas where we might be able to offer significant advantage over a more traditional approach.